So the definition from last class that we talked about, sampling distribution of p-hat. The distribution that would be formed by considering the value of the sample statistic for every possible different sample. So like you said, every possible combination from a given size. So our given size here is 5, 10, and 20. Every possible combination. We did that with really small populations last class. Today we're going to get, our population sizes are going to increase and be really big. So it would be impossible to take every combination of 5, 10, and 20 from your bag because you have 40 chips in there right now. And that would take forever. So we're going to be able to identify when we're given a population mean and a sample size, what the average would be, and answer questions based off of that. So if you can remember from last class, we talked about an unbiased estimator, and one of those was the mean. So do you remember from last class what that always equaled?
It equals your answer.
So our sampling distribution mean always equaled what?
The probability.
Yeah. It starts with a P.
Parameter.
The
probability.
No.
Parameter.
The sampling distribution mean always equal to population mean.
Oh.
I was close. I was in the idea.
So sampling
Can we say that again?
distribution mean
Where's that?
equals the population mean. That was one of the conditions.
Oh, this one now?
So our mu of p hat always equaled our mu. P hat is our sample proportion. We learned that last class. The second thing is that it always created a normal distribution. So 1 is that the means equaled each other. 2 is that it created a normal distribution. So let's look at these three. So we did our experiment. We calculated with sample sizes of 5, 10, and 20. And we then looked at the distribution that made. So if we look at our sample size of 5, what do you notice about the shape of that distribution? It's right skewed. Where would the center probably be?
8.5.
About around 0.2. Okay, let's move on to 10.
0.3. It looks normal-ish.
It's starting to look more normal. And where would the center probably be around here? Around 0.3 or so. Then we get to 20. Looks very normal. And where would the center be about? It's about 0.25. So if you were to count, so here our sample, or our population was 40. Count how many blue are in the bag. Go ahead and do that now. You already did it. There's 10. Cameron's got it for you. So if there's 10 out of 40, then what's my population proportion? P equals 0.25. 1/4 of them are blue. What do you notice as we're increasing our sample size?
It gets more normal.
It gets more normal. So,
You said that earlier.
so as n increases, becomes more normal. And then also, what do you notice about the standard deviation? And basically what I'm saying is the width of it. So here it ranges everywhere from 0 to 1. And then as it's increasing, what's happening? So is the standard deviation increasing or decreasing?
Decreasing.
It's decreasing.
That's what I think.
Is that what you mean? So my standard
I meant the average.
deviation is decreasing. Also, the center, if we know that it is actually 0.25, which one has a center at 0.25? Most likely the 20. Whereas the 5 and the 10, it might be 0.25, but this one is the most accurate. So my center is at 25. The standard deviation is decreasing, and it becomes more normal. So there is a specific way to check if we have a normal distribution. This one right here, not normal. This one right here, Probably not normal. There's two ways that we're going to check if it is normal or not. Here's another example just to show you on a grander scale, because we kind of did a small scale. So here's a study that was done at Cal Poly. It said that 43.7% were female of the 8,091 students. So 8,091 would be my population. And then from that, 43.7 were female. So we have a computer software that simulated 4 sampling distributions, sample size 10, 25, 50, and 100. And here are the pictures. So top left is samples of 10. Basically what they did is they went around campus and 500 times they gathered a sample of 10, sample of 20, or 25, 50, and then 100, and then counted the proportion of girls. What do you notice about where they are all centered for all 4 of them? 0.4, probably 0.437, because the mean is what? From the original problem.
2.7.
Yeah. So just eyeballing it, it looks around 0.45, but if we were to actually calculate it, it'd be 0.437. But I'm telling you, we don't have to do that. If you're going to know, you would take the frequency times the proportion.
It's just like 5%.
Yeah. What about the standard deviation? What do we know when it's going from 10 to 100? The standard deviation is increasing, decreasing.
Oh, decreasing.
Decreasing. And the shape is becoming more what? More normal.
This is easier than the stuff before.
And this is as sample size increases. So 2 ways to check if it is normal. 2 conditions. The first thing is in the problem, it needs to state that it is a random sample. So somewhere in the problem, it needs to say that they took a random sample. If it was a convenient sample, then there is no way that we can say it's a normal distribution.
It's a luster sample.
As long as it's random, it's okay.
Simple random sample.
And then secondly, your sample size needs to be large enough so that n times p and n times 1 minus p must be at least 5. So you can write
What?
n times p is greater than or equal to 5, and n times 1 minus p is greater than or equal to 5. So looking at what we just did, what was our proportion? How many blues were there?
2.
There were 10 out of 40, so that was 25%. So if I were to check whether something was normal or not, if I'm using this first one, my sample size is 5. So I'm going to say 5 times 0.25. Is that greater than or equal to 5? No. So then obviously this one's not a normal distribution. So I would not say that this one was normal. I could check 10. 10 times 0.25. Is that greater than or equal to 5?
No.
No. That's 2.5. So this one's not normal. 20.
Yeah.
20 times 0.25. That's equal to 5 exactly. So this one is exactly normal.
Why are you
See if it's normal.
Why are you multiplying it by 0.25?
That's my proportion. So I know that there are 10 out of 40 blue
Oh, okay.
in my bag.
I got you.
So I check 20 times 0.25 is greater than or equal to 5. That works out. And then 20 times 1 minus p, so 0.75, is greater than or equal to 5. Both of those work. So that tells me that using a sample size of 20 is okay. That's a normal distribution. And it was a random sample because why? What did we do? We randomly picked them out of the bag. So I could use this distribution as and call it normal. Those are the two conditions we check. From there, once we have checked those two conditions, we can say that it's normal. We can find the mean, the standard deviation, and the z-score. These three formulas do need to be memorized.
Oh, my lordy.
But the z-score formula we already know. We're just applying it to proportions. Value minus mean over standard deviation. So let's look at some examples now. We're going to check the conditions, describe the distribution. So it says a blind taste test is done to compare Coke 1 and Coke 2. Among n equals 75, so that means my sample size is 75, participants surveyed. P hat is the proportion preferring Coke 1. Assume that P equals 0.5, find the following. So first we need to check our conditions to see if we can answer questions based off of that. The first condition is that it is a random sample. Since it's blind, random sample, check. That's all I need to do. A little check mark next to it. Step 2, I need to use those two formulas and make sure that they're greater than or equal to 5. So n times P is 75 times 0.5. That equals 37.5, so greater than or equal to 5. I want you to show your work just like this. So say n times P, the number's plugged in, what that is, and then it's greater than or equal to 5. Then I check n times 1 minus P, which ends up being the same thing. That is also greater than or equal to 5. So that means that we have a normal distribution. When you're checking your conditions, I want it to look identical to this.
What if it's not?
If it's not, then you would say conditions are not met.
Okay, improve it.
Most of the time, the conditions will, I would say like 95% of the time, the conditions are going to be met. You just have to show that they are met. Otherwise, I wouldn't really want to give you a question because then you would have to stop right here and you couldn't answer anything.
Well, that's okay.
But you're just proving it. Remember those proofs from geometry? This is our proof. This is proving. This is proving that we can proceed and move forward. Then it says describe the distribution. When I say describe, I want the shape, I want the mean, and I want the standard deviation. So I would say that the shape is normal. The shape is normal. The mean is just equal to the number that is given, so 0.5. And then the standard deviation is that beautiful formula. So P1 minus P over N. You need your calculator. So 0.5 over 75. So somebody, actually let's all try this because we all need practice with our calculators.
You don't need to know. You just need to know. I need to figure out where she got with uniform.
This is 0.5.
It's in the question. It's in the question.
So what do you get for standard deviation?
You don't need to put that.
We need to do
0.0577.
0.058.
My name is Humpty.
Let's go 3 decimal places. 0.058. When I say the word describe, these are the three things I need. Normal, mean, standard deviation. From here, we can now answer any question that it asks because we've built a normal distribution, like from the last unit, that is now centered at 0.5. So any probability question that it asks me, I can just use normal CDF. So, next question. Yes. So, next question. The probability that the proportion is greater than 64%. So, I would say normal CDF 0.64 2 to the 99. And then I'm going to put in the mean and the standard deviation that I got from the beginning.
0.5 and 0.058.
Good. So I want you to get that. Then I want you to try the next two.
Random sample, we got.
So this is what we just said.
Random sample is 250 individuals say they never wear a seatbelt when driving. Suppose the population of people who never wear a seatbelt is 30%. That's terrible. I cannot believe that was so high.
I don't worry.
Does your car not yell at you?
It does like a couple seconds and it's
That makes me really upset. All right, describe the shape, center, and spread. So spread just means standard deviation. Center just means mean. So that's what I mean when I say center and spread. How am I going to figure out what this shape is? I have to pass two conditions.
Random sample.
Random sample, is that good? Random sample?
200 times 0.3.
No, you'll be fine.
200 times 0.3 and then 200 times 0.7. They're both greater than 5, so that means it's a what kind of normal? So shape is normal. Mean is what? What's the mean? 0.3. Because it's given.
3 times 0.7 over 200.
Mm-hmm.
This is just visual.
What do you get? 0.032.
Hands on.
Oh, there's another survey?
Okay, for this one, it's now changing the sample size to 400. I'm not going to make you go through everything again because it's the same survey, so it's random. What is the only thing that changes? My n changes, so out of the shape, center, and spread, I know the shape is going to be normal. What is my center going to be? Still 0.3.
Why wouldn't it be 0.25?
Because I'm only looking at the population number.
You're not looking at the 100 people over 400?
Mm-mm. It's my population.
It's just period.
So this has nothing to do with it. I'm not even using that number. I'm just using the n equals 400, n equals 200, and then the 0.3. What do I expect? My standard deviation. Do I expect it to be smaller or bigger?
Smaller.
Smaller. What do you get?
0, 2, 3.
Good. Here it gives me 20.9% of American adults smoked regularly in 2004. And then we have a sample size of 100.
It didn't say random.
It did not. But the question says, what symbol represents the population proportion? So what do I call, what symbol is that?
MP.
Just the population proportion. Just P. Just P, not P hat. P is for population. If I said sample, then that would be P hat. Okay. Then it says, here's a different type of question, but it's asking the same thing it's always been asking, just a different way to ask it. So it says, what is the CLT, which stands for Central Limit Theorem, which is a fancy way to say the thing that we've been checking, the n times p, the n times 1 minus p, just a fancy word to call it. So I don't even usually mention that, but you might see it. So central limit theorem, it's the same thing as saying np is greater than or equal to 5 and 1 minus p is greater than or equal to 5. That's what the central limit theorem is. You're just checking that your sample sizes are big enough. So I want you to check that condition below. So NP would be what? Two numbers multiplied together.
Shut up.
And what do you get?
I got it.
If you're multiplying anything by 100, what does it do to that decimal place? Moves it over. And then n times 1 minus p is 100 times 0.791.
How do we know this is random though?
I didn't ask if it was random though. It's just asking us to check the sampling, just the CLT.
No, it's not normal. Why not? They're both very low.
Yeah.
Never mind. Sorry.
So I would say normal distribution.
Hey, just want to know. Is how you want us to check it like that? Just n minus 1p.
N times p, n times 1 minus p. My mean would be what? Oh, sorry. Why did I say 0.3? 0.209. And then my standard deviation would be what?
Oh, this is a tricky one. Okay, 0.209 times 1.
Whatever that is.
Can you do that math in your head? How did it pass? It didn't ask us to pass tuition. You always have. I don't know what you're arguing with. I didn't come to that conclusion. Just the whole thing. Why are we doing this if it's not random?
You can just assume that it's random most of the time.
I'm not. I don't trust it.
Then you'll get the questions wrong.
That's how we get, bro. That's how
It wouldn't ask you follow-up questions if it didn't.
Sam Fung said never assume.
Well, Sam Fung is wrong in statistics.
No, literally, he said you cannot assume.
So what do you get for the standard deviation? Who put in their calculator? 0.041.
I'm missing so much, bro.
I saw him the other day during, I was reckoning.
So it wants us to draw a sketch. So what am I going to draw a picture of?
A circle.
No, not a circle.
A normal.
A bell. That is centered at
That's not a bell.
0.209. Shade the area corresponding to exceeding 0.25. So up here is 0.25. How could I find that area? No. Normal CDF.
Inverse normal.
What was it? 0.042? 041?
I'm tired of this formula. I'm writing French and so I think that's probably just a break. Thanksgiving.
What do you get?
I think Wednesday. I did it in
Do we have?
Okay, last part, part E. It wants us to change the sample size from 100 to 400. What's the only thing that changes? The standard deviation. So we're going to change that. We need to find a new standard deviation.
It's the 42nd.
Okay, so
No, it's not. It's gonna get bigger.
on C,
Yes.
do we have to draw the standard deviations?
No,
So like,
you don't need that. Just put your mean in the center.
I kind of want to.
Okay, that's also fine. Okay, what do you get for standard deviation?
69.
No. 0.020.
Is that close?
So to find that probability, normal CDF, 0.25, 2 to the 99, 0.209, 0.020. What do you get for that? You get 0.020 for the normal CDF?
Yeah.
You got it for both? Ah, couldn't try that again if I wanted to. Okay, one question that I did not put on there, but I feel like it needs to be because it's going to show up on the homework, is an inverse norm question. So we're going to create our own from this. What's the kind of question that it could ask where we would answer using inverse norm?
What kind is Z-score?
What percent?
Not what percent.
What probability?
Find the sample distribution.
No, that's normal CDF.
What?
It's like if a percent of like 70,
What's
it's like
the
find the z-score,
No.
something like that. It's
What
like
is
that.
the
No, it gives the z
area?
No,
Nope.
when we have to
Area is
find,
normal CDF.
isn't it when we have to find the z
Find the
score?
probability.
No, isn't it when you
That's
get to like a
normal CDF.
percentage or something?
Wait, you
Percentage.
sometimes be.
Like it's the
That's normal
70
CDF.
percentile. Of
Yes.
Percentile.
Cameron, say that again.
70 percentile.
Okay, what's the 70th percentile?
Point.
I remember that because boy, that test had me struggling.
Okay, so we're going to add this as
Big
part
numbers.
F. What is the 70th percentile? Inverse norm, point
Isn't it like
70.
mean standard deviation and like 0.10 or something like that?
And let's use the original standard deviation, not the part E one.
0.41.
So this is from part A through D. What do you get for that? 0.231. Okay, what's an example where you have to do 1 minus the percentile?
If it's above the 70%.
What if it, like, what would the question say?
Top. I still don't.
The top,
Yeah.
95th
Five.
percentile.
The top.
the
bottom.
top 80% tile.
So, what is the top, let's say, 28%?
Minus 28, 90, something. Like
So I would do inverse norm,
Is it 70?
0.72,
Yeah, buddy.
0.209, 0.041. You should get 0.2 something, 2.4 maybe, I don't know.
Did you just do inverse norm in your head?
Yes. Genius.
Are you right?
0.23.
She's obviously taught this class. She remembers this example.
She said point. We just literally created that.
It's an Oreo.
0.23. You really said 0.24.
Okay, homework. I'm changing it to be 113 through 116 in the book. Do next class.
Pages. Oh,